let's get started. So if we got a hexagon, remember, we're going to break it up into those equilateral triangles with the 60-degree angle in the middle, right?
Yeah.
So the radius being 3, we can already just jump in and do the problem right away, right? 1/2 times 3 squared times the sine of 60. And then there's 6 of them, so we'll just take all that and times 6, right? So it's literally just throw that in there and what do you get, right? What do we get? We get 23.3826859. And remember, we always round to 4 decimal places when we're not told otherwise. Right? And then the perimeter. Well, that's even easier because we already know if you know the radius, you know the length of the side. They're the same, right? So in a hexagon anyway. So if each of the sides is 3 and there are 6 sides, what's that perimeter going to be?
18.
Got it. 18. Good. All right, let's do same thing with our square here. If you've got a square and you know the side is 4, what does the area have to be?
15, 16.
16, right? 4 times 4. And then the perimeter, what's the perimeter going to be?
See.
Yep.
Because you're, yeah.
Yep, exactly right.
4, 4.
That's right. Very good. All right. So now, last thing, we got to use the Pythagorean Theorem.
I know, yes.
What is it?
Square root of 53.
Show is. Very good.
I'll forget.
Yeah.
I forgot how to do it too.
Square the 2 legs, add them together, and square root it. Eh? That's all it is. All right, square the 2 legs, add them together, and then square root. And if we leave it as radical 53 here, that's fine. They don't tell you how to do it. So if you just leave it as radical 53, that has given you the answer to the problem in a way that satisfies the directions, right? And of course, you could always take the square root of that and get 7 point something, right? Okay. You feeling good about this? Pretty easy? Good. Because these are the skills we need today. So if you can do that, you can do anything. So what we're going to do today is we're going to find the surface area and lateral area of a pyramid. So just like on Monday when we did it with a prism, same idea today. It's just going to be that the formula is slightly different because the pieces are slightly different, right? What do you mean? Well, here, let's look. Pyramid, right? Notice how this is different. Monday, when we had a prism, there were 2 bases, a top and a bottom, right? Today, there's only 1 base. On Monday, with the prism, because they had the 2 bases, top and bottom, all these lateral faces were all rectangles, right? But now, since they all come to a point like this, they ain't rectangles no more, they're triangles, right? So this is going to change how we have to figure out the pieces. Second most important thing to notice, in addition to all that, since we're looking at figuring out the area of each of the faces, the height isn't part of a face anymore, right? When we did the prism, the height was like the width of the rectangle. Not so much anymore, right? Now you see the height's here. what we want is we want the altitude of the triangle. We want this thing right here. They call it the slant height, and they label it with the letter L. Okay? So, and I will say I really do like this diagram here. It really does help sort of explain what's going on, right? We've got one base, and we've got all these lateral sides. The perimeter of our base covers all the bottoms of all those triangles, right? So just like before, the perimeter is going to be part of our calculation, right? But this time it's no longer just base times height, because we're not dealing with rectangles, we're dealing with triangles, right? So now, since the triangle formula is 1/2 base times height, we're going to have 1/2 thing times thing, right? So there's a lot of stuff going on up here, but our surface area formula is just going to be, there's one base plus the lateral area, which is now, since it's a triangle, 1/2 times the perimeter of the base times the slant height. Because the height of those triangles isn't the height of the pyramid anymore. It's the height down the side of the pyramid, right? Does that feel okay? And now that we've done this discourse, literally everything else that we do today is going to be the same idea. Sometimes they're going to give us the height of the pyramid and expect us to find the slant height, but we just did that in the bell ringer. We used the Pythagorean Theorem, found the missing side, and then we're good, right? That's all. Everything else, identical to what we were doing on Monday. All right, so let's go ahead and figure out the surface area of this hexagonal pyramid. So just like what we did before, we're going to figure out the area of the base, perimeter of the base, and the slant height. So area of the base, perimeter, slant height. I'm just writing that all down so I don't forget. Area of the base, just like we did in the bell ringer. All these sides are 6. The angle is 60. We know and then there's 6 of them, right? That's all there is. So now I personally, because I know I'm going to have to write all this down, I'm just going to multiply all the numbers and leave the sign of 60 by itself and deal with that later. Okay? So 6 times, got to be on in order to work. 6 times so these numbers, when you multiply them all together, you better get 108. And then just leave the sign on the outside like that. Just like what I was talking about on Monday. I think it's easier to write it out like that, just because I don't have to write out all those big long decimals, right? So like, now that we've done that, that's the hardest part out of the way. Let's find the perimeter, let's find the slant height. Perimeter. How many sides are there? And each of them is 6. So what's the perimeter?
36.
Yeah, 36, right? 6 plus 6 plus 6 plus 6 plus 6.
Which would
plus 6.
essentially just be 6 times 6. Yeah.
Exactly. And then the slant height, well, they give it to you, right? That's the easy one. And then we're just going to do this, right? One half PL. And then we're just going to throw that into the calculator. Make sure to close your parentheses after that sign, because it's going to throw your answer off if you don't do it. Remember, we want to round that to the nearest 4 decimal places. We got 255.5307. And my units are inches squared. The area is not always the same as the perimeter. No, it is not always the same as the perimeter. Usually not. If the area and the perimeter are the same, it's a coincidence. Like in the bell ringer, that square, that situation, that was a coincidence. Somebody ringing my phone and then hanging up on me.
For a square, like for a perfect square, it always is because all the sides are the same.
Yeah, so if you've got a square, when it's 4, it'll work like that. But like if it was 5, then it wouldn't work. 4 is just the perfect number to put it in where it happens to work, right? Every shape is going to have one.
A coincidental.
Yeah.
Yeah.
Every shape's going to have one, but the square is basically the only one where it's like gonna happen and have it be like any good, to be honest.
How'd you get 255? Like that?
I put 108 times sine of 60, close parentheses, plus 1/2 times 36 times 9 into the calculator, hit the enter button, and then I wrote it down. Just from here, just calculator time. Oh, no, it's not a dumb question. It's a good question. There are certain situations where, yes, the area and yes, the perimeter are the same. And it's just something that happens every once in a while. It's good to know, hey, well, it's not always going to be the same. Because our brains do tend to do that thing where they like find patterns that aren't there. It's an evolutionary thing that we as humans do. We do a lot of pattern recognition to protect us from predators. The problem is sometimes pattern recognition is not good. It happens. So those are the same as the number. Uh-oh. What did you type in? Here, let's see. Probably because you didn't type something in correctly. Here, let's see. No, if you forgot to close a bracket, it would have thought all the stuff was on the inside of the sign. Let me see. You're killing me. No, let's see.
First time I got like 15,000, 1,000.
Yeah, 108 sine of 60. Then you're going to do plus.
Oh, that makes sense.
Right. And then not 2, but. Oh, I think I see what you're. Just 2.5.
That makes more sense.
Yeah.
One more question?
Yeah.
How'd you get 108?
Half of 6 squared times 6. I just combined all my like terms here.
Oh, okay. Yeah, I didn't see that. Thank you.
Yeah, no problem. All right, we feeling good?
Yeah.
All right, your turn. Now it's a square pyramid. The base edges are 5 and the slant height is 3. What's the surface area of this whole pyramid? All right. Okay, let's go over this. So the key to doing, and this goes for the prisms too, the key to doing these and doing them correctly is taking a second to think about what shape are we actually dealing with there on the bottom. And So like, here we got a square. So if we know that the edges are all 5, for a square, it's just 5 by 5, ain't it? So the area of that base is just 25. And then for the perimeter, all the sides around are 5. For a square, 5, 5, 5, and 5, 20. All right? And then the slant height, well, they give it to you. So now all we do is we put it into the formula. Don't forget your units. Your units here are meters. Here we want the lateral area. So lateral area, we don't want the base, right? So we want just the 1/2 PL part, right? So before I even start, let me write that out, because earlier today I screwed up. I was like, I did the whole thing, but you know. So here's the dimensions that they give us down here, right? I want you to notice they did not give us the slant height. They gave us the altitude height. They gave us the from the floor to the ceiling height. We don't want that. We want down the side, right? So we're going to have to do a little bit of work with Mr. Pythagoras, right? Let's do the easy part first. Let's get the perimeter out the way, because we know that one of those sides of that square is 30, ain't it? So here, 30 times 4, which is 120 all the way around. Now, slant height. Let's take care of this. Let's take this triangle in here and let's bring it out here so we can actually see it. They tell us this height here is 36.4. And they tell us this piece right here. Well, they don't tell us this piece right here. But,
15.
Yeah, why is it 15?
Well, if the side is 30,
Uh-huh.
divided by 2.
Yeah, that's all it is. The whole side was 30, but from the center to the side is what we want. So the whole thing is 30, 15, right? So it's going to be 15. And what we want is the slant height. Well, we know how to do that. That's right. Now, here's what I'm going to tell you. In these problems, rarely, if ever, are they going to come out really nice. So I want to show you what you might want to do. And again, you do you. If you don't want to do it this way and you want to write out a big, long, hairy decimal, you can, but no, I'm not going to do that. That's not the way I'm going to go. So I'm going to square those. 15 squared is 225. 36.4 squared is, well, let's find out in the calculator. Thousand something, 12, whatever. So when we square those and add them up, we get 1,549.96. That's what we get when we put everything all together, right? I'm not going to square root that. I'm just going to leave it in radical form and then deal with it later. I'm just going to leave it like that and then let future me deal with it. Right? Because I just have to do 1/2 times P times this thing. Just throw that into a calculator and then get my answer and then round to the nearest square meter like it said, right? So 1/2 times 120 times the square root of that thing, hit the enter button. And here's what we get. We get that, right? And then it says round to the nearest square meter. We're just gonna look at that and say, all right, well, that's a 1, so we're gonna round down. And then our final answer, which I'm gonna put up here in the upper right-hand corner, is 2,362 meters squared. Right? So a problem like this, they're not asking you to find the whole thing. They're trying to just have you find all the triangles, right? So for me, it's like, okay, well, let's find the perimeter of the base. Let's find the slant height. Multiply those together, divide by 2, and then there you go. Right? Now it's your turn. Do it with a hexagon. Let's go over this. So we want perimeter and slant height. Well, perimeter is real easy because it's just 36 all the way around. So if it's 36 in all 6 of those spots, we know that the perimeter is what? 216, yeah? 36 times 6?
Yeah, that's what I did.
Cool. Well, as long as you did it, I know it's right. Now, slant height. Well, we need the other part. Yes, sir?
Square root 1,880.
I got 2,088.
Well, yeah, that's not out here.
So let's talk about what to do, because I think both of you were wrong.
Oh.
Oh, well, yeah, I got it wrong, I think.
Right? Square 42, square 18 radical 3, add those together.
Oh, radical 3.
Right? That's what that is, 18 radical 3 feet.
Oh, I didn't see that part. Yeah, that explains it then.
Is that 54? So it's
18 squared times 3. Right? Square 18, square radical 3. Keep typing into it when it's turned off. Then I feel really dumb. Like I'll pick it up, I'll start typing, and then look at the screen halfway through. It's like, oh,
Oh, it's, yeah.
oops. All right, now that we've fixed our calculations, what did we get?
Well, 1,818.
You're closer.
I'm still wrong.
972.
We're so wrong.
42 squared plus 18 radical 3 squared. Parentheses, 18 radical 3, close parentheses, squared.
Oh, I got it now. I just did in parentheses the 18 and 3.
So this is just going to be radical this number. Still having trouble?
Yes.
For that times, you're going to add 42 squared.
I did too, but that's because you didn't bracketize the 18 and then 3 and then put a square.
Oh,
Yeah,
That's how you're supposed to do it, yeah. As soon as you put them right there, it
so
fixes
now
itself.
let's open this problem.
So then from here, it's just 1/2 times that, right? So the 1/2 216 times this thing. And just put it in the calculator, and what do you get?
I'm pretty sure I got it.
What'd you get?
I got 5,649. Oh, right. 5,649.133031.
And then we round to 4 decimal places. Oh no, it says to the nearest square foot, my bad.
So it would just be 6.9.
Yep.
I thought I got it wrong because the answer was bigger than the square root.
Well, yeah, it's bigger than the square root, but you're doing 1/2 times 216 times that square root, right?
Yeah, I got it now. It just feels weird in my head.
Yeah. Sometimes it's just we're overthinking. It happens a lot. Cones. Now, again, the book is going to try and convince you that a cone needs to be treated differently than the rest of these. It really doesn't. They'll even give you a formula for it. They'll be like pi r squared plus pi r l. But here's the thing. That is still the exact same thing because the area of the base for a circle is pi r squared, right? And then what they did here is they took 1/2 times 2 pi r, canceled those 2's out. So what is this? This is just 1/2, because this is the perimeter times the slant height. Same thing, isn't it?
Yeah. That dang book.
I mean, like, listen, I'm not going to say, the person who wrote this probably thinks that this is helpful. And for some of you, perhaps you feel like this is helpful too, and that is totally valid. I'm not a memorizer. I don't like memorization. I really, really, really do hate it because it doesn't help me. When I try and memorize stuff, it just goes away. My 3 brain cells can't hold on to stuff. So the less I have to remember, the easier it is. And plus, you know, if it's a situation where I can do the exact same thing every time with every single problem, suddenly it's an easier process for me to internalize, right? You know, it's like you're practicing an instrument or a sport. You're doing repetitive motions over and over and over again until your body figures out how to do it automatically, right? Like I think about, you know, practicing the cello for 4 hours so that I can get this one piece of music. I once did that. There was like 3 bars worth of music to get that right. It was a ridiculous run from like the bottom of the cello to the top of the cello and all the way back down. And it's like I just spent 3 hours practicing that just so that I could get to the point where I didn't have to think about it anymore. Same thing here. I'm not saying you need 3 hours, but like
That was a couple like years of venting built up just to talk about your cello practice.
so the piece is Introduction and Polonaise Brillante by Chopin. It's like a little cello showpiece. There's a really nice story behind it. Let's finish this and then I'll get back to it. But there's a part in the middle that is very difficult. Like the whole piece is pretty difficult. The part in the middle is like double plus extra difficult. It's just like years and years of me like, oh, God, okay. Never mind. Okay. So anyway, surface area of a cone. I'm just going to do it the same way I have been doing it. Just, you know, in this case specifically, the area that we're looking at is a circle, so pi r squared, right? The perimeter that we're looking at is 2 pi r. The slant height is what's given. So look, here's the radius. 15 squared is 225. Don't forget to put your pi on it. 2 pi r. Well, 15 times 2 is 30. Don't forget your pi. And then the slant height, they give it to us. It's right here. It's 25. So now it's just same thing. B plus 1/2 PL. So times 25, right? And then just doing that. This is 225. I want to say this is something 75. 15 times 25. $375 or 75? $375. Then you add those together, 600 pi. Again, don't try and think about this too much. These are centimeters squared. Okay, here's yours. You want to find the surface area when the radius is 16 and the slant height is 28. Give the surface area in terms of pi. So once again, you know, it's just with a cone. So it's just pi r squared for the base. Well, the r is 16. So what's 16 squared?
16 squared is 256.
Yeah, so this is going to be 256 pi, right? Perimeter, just 2 pi r. So we got 32 pi, right? And then the slant height's 28. Again, you've got all your things now, just put them in. Times 28. And we're leaving it in terms of pi. What was half of 2 times 30? Half of 32 times 28?
I did 16 times 28, which in my answer was 448.
448, you say?
Uh-huh.
And then 448 and 256 leaves us with like what,
704.
4 pi. And my units are meters squared.
Still a big cone.
That's a very big
Massive
cone.
cone.
Well, 16 meters in radius is like,
Like a room cube or a room cone.
yeah, 50 feet-ish.
And then the 28 meters, that's like a 75-foot tall, well, slant height, and just slant height alone.
Yeah. Mm-hmm.
Cars, the movie. It's like on traffic cone, like the houses.
Exactly. Exactly. With these, it's just, now they're just doing the slant height, right? So we don't even, you know, this is 80, that's our diameter, so our perimeter is just 80 pi. Slant height, well, we got to figure that out. This is 40, this is 45. What's 40 squared plus 45 squared? Anybody? Like 3,000 something, but like what actually is it?
40 squared plus 45 squared?
Yes.
Dude, I got like 3,625.
Perfect. Good. Then it's just, we're just doing the slant height because we're just doing the lateral area because they want like the filter, right? And that's just the nap of the cone. It's not the base of the cone. By the way, that's the name for the pointy part of the cone, a nap.
And now,
Yes.
sleepy cone.
A nap. But anyway, we just do 1/2 times the perimeter times the slant height. We get our answer, which is
You need me to check.
yes, please.
I feel like you could do that all in your head.
Me? No. Because radical 3625 is not a perfect square. So I would be sitting here doing like,
Do you want it in terms of pi, or do you want like just the full answer?
In terms of pi, it's still going to be a decimal. So give me the whole thing with pi and everything all in there.
I got 7,565.957 013.
That zero is going to go away. I'll put a zero here. And then that's millimeters squared. All right. Same thing. Just a matter of, they give you the height again, not the slant height. So a radius of 10, a height of 28, not a slant height. And then we just want the lateral area again. So again, we just want that. Same idea, right? We got perimeter 25 because we got the radius. Slant height 28 squared.
784.
Thank you. So we got 884. We're just going to square root that. We're going to come up with half times this times that. We get this, and we're rounding to the nearest whole number. Inches. Right?